Good morning, good afternoon, or good evening. This is Mr. P. Today we're going to be doing our section 13.6 in the secondary math 2 honors section, sequences and series guided notes. Let's get to it. Sequence is an ordered list of numbers. There can be a limited number or an infinite number of terms in the sequence. Finite sequence is a function who has a limited number of terms, whose domain is the finite set 1, 2, 3, up to n. An infinite sequence is a function that continues without stopping, and whose domain is the set of positive integers, 2, 4, 6, so on and so forth. So write the first 6 terms of the sequence. So a sub 1, it's trying to tell you, is going to be 1 plus 4, which is 5. A sub 2 is 2 plus 4, which is 6. A sub 3 is 3 plus 4, which is 7. And at this point, hopefully you see that the sequence is going to go 5, 6, 7, 8, 9, 10 to get the first 6. All done. You can also say it like this: f of n equals negative 2 to the n minus 1. So f of 1 is equal to negative 2 to the power of 1 minus 1, which is negative 2 to the power of 0, which is 1. F of 2 is equal to negative 2 to the power of 2 minus 1, which is negative 2 to the power of 1, which is negative 2. F of 3 is negative 2 to the power of 3 minus 1, which is negative 2 to the power of 2, which is 4. And maybe you can at this point see that this is going to go 1. 1 times negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Positive 16, negative 32. Do you see how we double it and then change the sign each time? If not, you can do this by hand. You can keep going. F of 4 is negative 2 to the power of 4 minus 1, which is negative 2 to the power of 3, which is negative 8, just as I said. Ha! Describe the pattern and write the next sequence. So negative 3, negative 1, 1, 3. What do you think? What am I doing each time to the previous term? Yeah, I'm just adding 2. So adding 2 to the previous term. That is, it's going to go negative 3, negative 1, 1, 3, 5. 5 is the next one. 1, 3, 9, 27. What's happening here? I added 2, I added 6. It's not working. So what do you see? Yeah, multiply the previous term by 3. So this would go 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. A weird-looking 27. And 27 times 3, is that 81? It sure is. Yay! And 81 is the next term in the sequence. You agree to work for your uncle. You earn $10 the first day, $20 the second day, $40 the third day, and $80 the fourth day. Holy crap. That's pretty good. So describe the pattern and write the next term in the sequence. So the pattern, it goes 10, and 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. And 80 times 2 would be 160. So the amount earned each day doubles the previous day. Let me get the green out for that. Cha-ching! Cash register sound. You are rolling in the money. So let's put that on a coordinate plane really quickly. X is going to be the days of work, payout for that day. And we're going to just count by tens. 10, 20, 30, 40, 50, 60, 70, 80. I'm not going to make you go any further than that. 1, 2, 3, 4, 5, 6, 7. Oh man, I would work for this uncle every single opportunity I could, because on the first day you're going to make $10. Second day he's going to give you 20. Third day you're going to get 40. Fourth day you're going to get 80. Fifth day you're going to get 160, which is way up there, and you can already see that this thing right here has got one of those awesome exponential curves to it. Something like that. Series and summation notation. When a term of a sequence are added together, the resulting expression is a series. A series can be finite or infinite. Like finite series 2 plus 4 plus 6 plus 8 is something you can totally just add up. 2 plus 4 plus 6 plus 8, and that's 20. However, an infinite series would be 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus blah, 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 blah. And for what it's worth, that particular series, you can probably tell, is just going to go on, like go as high as you want it to. Like if I said, well, are you ever going to reach 100? You'd say, yeah. If I'd say you're going to reach 1,000, you'd say, yeah. And if I'd say you're going to reach 1 billion, you'd say, yeah, it would just take some time. There are ways to add those up, but not until quite a bit later. Summation notation is way easier to write that. So the two series above can be written as the summation notation. That is 2 plus 4 plus 8 plus 2 plus 4 plus 6 plus 8 is the summation of I equals 1 up to 4 to 2i. That is 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. That's what that's saying, is that you start I at 1 and then you add those all up. So for example, 4, 8, 12, 16, 20. So you can see that that's 1 times 4, 2 times 4, 3 times 4, 4 times 4, 5 times 4. So this is the summation of I equals 1 up to 5, because there's 1, 2, 3, 4, 5 terms, of 4 times I. Why? Because that would be 4 times 1, 4, plus 4 times 2, 8, plus 4 times 3, 12, and so on and so forth. That's the summation notation I want from you. This one, oh, it doesn't want us to actually add, thank goodness. 1/5 plus 1/25 plus 1 over 125 plus 1 over 625. Ew. Well, do you remember checking if these are geometric? Do you remember doing that last time? Well, not last time, in secondary math 1. So if you do 625 divided by 125, I get 5. If I do 125 divided by 25, I get 5. If I do 25 divided by 5, I get 5. That is, this is the sum 1, 2, 3, 4. I equals 1 up to 4 of 1 over 5 to the power of n. Why? Because that would be 1 over 5 to the first plus 1 over 5 squared plus 1 over 5 to the third, and so on. Those can be tricky to recognize, which is why I want you to bring back that secondary math 1 skill of looking at what kinds of series we have here, okay? Finding the sum of a series. The series from n equals 2 up to 5. So that's going to be 2 over 2 minus 1 plus 3 over 3 minus 1 plus 4 over 4 minus 1 plus 5 over 5 minus 1. We stopped at 5 because it told us to stop at 5. N equals 2, start at 2, take it up to 5. Let's simplify these. 2 over 2 minus 1 is 2 over 1. 3 over 3 minus 1 is 3 over 2. Plus, oh, I'm starting to get it, 4 over 3 plus 5 over 4. Gross. So I need to give these a common denominator. So I'm going to do this by 2. That turns into 4 over 2. 4, 5, 6, 7. So 7 halves. That's what I get when I added these two together. Plus 4 over 3 plus 5 over 4. I would rather do the halves than the 4. So we're going to go ahead and we're going to say multiply that by 2 and 2. Why am I doing this? So that I can add these two together. 14 fourths, excuse me, plus 5 fourths is going to be 19 fourths, which leaves me to 19 fourths plus 4 thirds. There's nothing I can do about that. So I'm going to multiply that by 4 over 4 and that by 3 over 3. This is gross and makes me feel yucky. 19 times 3. Why did they do these numbers? Ew, ew, ew. 57 twelfths. Plus 4 times 4 is 16. 3 times 4 is 12. That's why we did it. 57 plus 16. Yuck, yuck, yuck. That's 73. Ugh, 73 twelfths. Gross. No thanks. I didn't care for that at all. What are you going to do? Now this one's I equals 1 up to 8 of I squared. That is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared. And hopefully remember our perfect squares. That's going to turn into 1 plus, there we go, 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 8 squared, which is 64. I'm just going to grab my calculator. 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64. 204. There. Now you know what the first 8 perfect squares are when you add them together. 204. And, oh, that was it. Okay, so that was just sort of some basic stuff about sequences and series. Maybe it was a little bit of a review. That's all I got for you here, folks. If you have any other questions about this, please contact your instructor. This is Mr. P signing off, and I hope you have an excellent rest of your day.